Forests and natural environments in Ireland are increasingly at risk from hazards like droughts, floods and landslides. These can damage ecosystems, reduce biodiversity and disrupt water systems. This system collects and analyses real-time data such as temperature, soil moisture and rainfall to detect patterns and provide early warnings. It helps to predict and respond to dangerous conditions before they escalate, supporting organisations like Met Éireann and environmental researchers. This section demonstrates the embedded system. The master microbit acts as the control unit, receiving data, processing it, and providing outputs. The on-start block sets up the system by configuring the radio so all microbits can communicate, and it displays master to show it as the main device. The system uses digital input through button A and button B. Button B starts the system by sending a signal to the sensor microbits to begin transmitting data and enabling logging. Button A stops the system by stopping data transmission and disabling logging. The system also uses analog input by receiving continuous sensor data such as temperature, soil moisture and precipitation via radio and assigning these values to variables. The forever loop makes the system automatic. Once started, it continuously receives the data and logs data without further user input. Finally, the system processes the data and if certain conditions are met, displays warnings using LEDs and sound. When button B is pressed on the master microbit, the system begins to run automatically. The microbit continuously receives data, processes it, and generates outputs without any further user input. This Python code collects environmental data from the microbit and saves it to a CSV file. First, a serial connection is established with the microbit. Then, the user chooses to create a new file or use an existing one. The program then continuously reads incoming data from the microbit. The data is decoded and split into temperature, soil moisture, and precipitation. Each value is converted into the correct format. The data is displayed in real time. Finally, it is saved to a CSV file for later use in the risk model. These are the sensor microbits. They collect environmental data such as soil moisture, precipitation and temperature. This data is then sent via radio to the master microbit and passed to Python. The master microbit receives data using radio communication. It processes the incoming data and responds by displaying different icons on the LED screen showing the data is received. Here, Python is receiving data in real time. As the sensor values change, new data is received immediately. The received data is stored as a new row, allowing the data to be recorded and used later in the risk model. This code controls the process simulation on the master microbit. First, the microbit receives data using radio communication. The incoming data is stored as the temperature, soil moisture and precipitation. The microbit then continuously checks this data using conditional statements. For example, this condition checks if soil moisture and precipitation are low and temperature is high, indicating a drought. When this condition is met, the microbit displays the icon D and displays a warning sound. This shows how the microbit acts as the brain by analysing data and responding to dangerous environmental conditions. Under normal conditions, the microbit displays an N and plays a normal sound. When the drought condition is met, the microbit changes the display to a D and plays a warning sound. This Python function calculates the environmental risk level using soil moisture, precipitation and temperature data. It compares the values to set thresholds using conditional statements. These thresholds were based on Irish research including Met Éireann, linking dry conditions to drought and wet conditions to flooding and landslides. For example, low soil moisture and rainfall with high temperature indicates drought, while higher values indicate flood or landslide risk. The function then assigns a risk level, which is displayed beside the incoming data in real time. Here the incoming sensor data is displayed in real time. For each reading, the Python program calculates and displays a risk level beside the data. As the values change, the risk level update automatically. In this scenario, I test what if temperature increases and rainfall decreases, representing drought conditions. I increase the light level on the temperature sensor using a lamp and decrease the light on the soil moisture and precipitation sensors by covering them. This simulates high temperature and low rainfall. As a result, the system detects a drought risk. The microbit displays a D and plays a warning sound, demonstrating how the system predicts drought risk under changing environmental conditions. Next, I test what if rainfall and soil moisture increase and temperature decreases, representing landslide conditions. I increase the light level in the soil moisture and precipitation sensors and decrease the temperature to simulate weather conditions. As a result, the system detects a landslide risk. The microbit displays an L icon and plays a warning sound. In this section, the system becomes adaptive, as Python now makes decisions based on the calculated risk level. The program calculates the risk and sends it back to the microbit using serial communication. The microbit receives this and activates an output, for example, displaying N for normal conditions, while also playing a sound. This is different from the process simulation, where the microbit made the decisions. In conclusion, this system collects environmental data, predicts risks such as drought, flooding and landslides, and responds automatically to changing conditions. It provides an effective way for organisations to monitor environmental hazards.